Chapter 8 is all about advanced operators. If you recall from earlier chapters, the operators that we've already seen are the arithmetic operators, in other words plus, minus, divided by, and multiply, and also the fifth one, modulo, and the relational operators, which include greater than, less than, equal to, greater than or equal to, and so on. We've also seen the relational operators and or. So anyway, there are quite a few more operators available to us in the C language. Some of them are derivatives of the ones we've just mentioned, and some of them are brand new. Let's have a look at the first set. The first advanced operators we're going to have a look at are called assignment operators. An assignment operator is actually a combination of a regular arithmetic operator, such as plus or minus, and also an equals assignment statement. Let's have a look at the 5 arithmetic assignment operators. They are simply plus equals, minus equals, multiply equals, divide by equals, and modulo equals. Let's see an example of one in operation. We might say x plus equals y minus 3. Now this is a little bit like saying x equals y minus 3, except that instead of evaluating y minus 3 and then assigning the value into x, we evaluate y minus 3 and then we add the value into what was already in x. In other words, it's equivalent to doing x equals x plus y minus 3. Those two statements are absolutely identical in every way. There are actually two subtle differences. One is it's obviously less typing for the programmer to type the above example, and the above example is also slightly more efficient when it comes to executing in machine code. So if you use the assignment operators wherever possible, your program will run slightly faster. We'll have a look at some examples of that, but before we do, I'll just show you the other assignment operators, the ones that are not arithmetic. We have and equals and or equals, as well as the 5 bitwise operators, bitwise and bitwise or equals, bitwise not equals, and bitwise shift left and shift right equals. Now you don't know anything about any of the bitwise operators yet. We'll be covering all of those in a later chapter. I just wanted to show you that once you do know them, you'll be able to construct assignment operators for each one of them in exactly the same way. They really are no different to the arithmetic assignment operators. If you use the same basic rule for getting their equivalents, as I've just shown you above, then they will work just as you expect. So, having said all that, let's now move on and have a look at some examples of arithmetic operators. Here is assignment.c, and as you can see, we've got two little assignment statements happening here. One of them is an arithmetic assignment using the plus equals arithmetic operator right here. So, what do you think you'll get if you run this particular program? What do you think the printf will actually print for you? Well, let's just check to make sure that we know. We might think we know, but let's just check. Well, we don't actually print out the value of y, but if we did, I'm sure it would be 3. But what about x? Would it be fair to say that the value of x when printed down here will be 4? What do you think? Will it be 4? Well, I actually don't think it will be 4. So that answer is incorrect. And why is that? Well, you might get extremely fortunate and have it happen to be equal 4, but let's have a look at what's actually going on here. This says take 4 and add it to whatever is already in x. So what is already in x? Well, nothing. X is currently uninitialized. Nothing has been assigned to x. You might recall that is not initialized will contain a random value. So x contains a random value before it reaches this particular line of code. So obviously then if we add 4 to a random value, we're going to equal a different random value. So x could be anything. It might be 4 if we're lucky, but then again it probably won't be. So we actually need to put some sort of initialization statement in for x. Let's do that now. We could say x equals 1. So now when we run this, we should get x equals 5. Let's see if that actually works. We compile, and that was no errors. And now we run, and we see that x does indeed equal 5. Moving on, we could make this a little more complex. We could say x plus equals y minus 7. So what will that give us? Well, let's do the arithmetic. We've got x would currently be equal to 1, and then we add to it y minus 7. Now y equals 3, so we're adding to x 3 minus 7, which is negative 4. So we're adding negative 4 to a value of 1. So we end up with negative 3. Let's check that. Compiles and run, and we get x equals negative 3. Good. Let's try a slightly different example. Let's make x equal to 100, and let's say x divided by equals y minus 1. Now what's that going to give us? Well, we're going to be dividing by y minus 1. Now y minus 1 is 3 minus 1, which equals 2, so it will be 100 divided by 2, and put that value back into x, so x will then equal 50. Let's check that. It runs, and it compiles, and there we have x equals 50, as expected. All the other arithmetic assignment operators work in exactly the same way, so I don't see that we need to go into those at this point.